Hey, I think we have here today a very interesting integral. This one's from the MIT Integration Bee 2022 regular season problem 6. We have the integral of 3x cubed plus 2x squared plus 1 all over the cube root of x cubed plus 1 dx. Now I gotta say I found this one really tricky. I actually tried it I think 3 or 4 times before I got something that worked. The thing that I found tricky was kind of like this numerator is really suspicious. You can kind of see there's a lot of different ways to factor it and a lot of ways to try to simplify this, and it wasn't clear to me which one was going to work. What I arrived on as a pretty good way was to actually break up this 3x cubed. We'll write it as, what I'll do is break this 3x cubed up as, let's write this as x cubed plus 2x cubed to separate it. So if I have x cubed and I group it with my plus 1, that's kind of nice because we have this x cubed plus 1 here. Then what we have left over is we're going to have this, we can't forget this 2x cubed, and then plus 2x squared. And then it's nice having this x cubed plus 1 here, but then this is also pretty easy to factor. I can take a 2x squared out of this, and that's going to give us 2x squared times just x plus 1. And then because we have this addition here, what I can do is break this into two integrals, and let's see what we have. Now from here we have this split up, but it's still not quite clear what to do. But one thing I like here is, okay, so we can look at this x cubed plus 1 as to the 1 power, and this we can look at as to a 1/3 power. And so we can combine these and write this as x cubed plus 1 all to the 2/3. And then with this integral on the right, the interesting thing here is it looks like we can almost do a u substitution. Now, you notice like if our u is x cubed plus 1, the derivative of this is going to be 3x squared. Well, we have a 2x squared here. What I'm going to do with this 2x squared, let's bring the 2 out front and force it to be 3x squared. And then we'll divide a 3 so we're not changing it. And then from here, I think what I'm going to do is focus on integrating just this one for now, but I'm going to need to clean up the board to get some more space. Okay, now continuing with this integral on the right, like I said, we have something we can integrate here. Now, the only problem is what about this x squared plus 1? Well, that's a perfect case for integration by parts because we can differentiate x plus 1 easily, and we can integrate this thing. So let's do integration by parts using the DI method or tabular integration. So with our DI table, what I'll do again, we'll differentiate x plus 1, and we'll integrate this 3x squared over the cube root of x cubed plus 1. Now the derivative of this first derivative of x plus 1 is just 1. That's nice. And then for this integral, we'll just kind of do this in our head, because like I mentioned before, if this is u, then now we have our du in the numerator here. So what we're actually integrating is u to the minus 1/3. Let me just kind of informally do this over here. So if we're integrating u to the minus 1/3 du, that's just going to be u to the 2/3 times, we bring 2/3 in the denominator, we'll have 3/2 in front. So for this integral, we're going to have just 3/2. Our u is this piece, so we're going to have 3/2 x cubed plus 1 to the 2/3. We'll have part of our solution right here on the diagonal, but I want to remember to multiply that. We have this 2/3. I need to multiply that back in. So when we put this together, the 2/3 and the 3/2 is going to cancel out and give us 1. So part of our answer is going to be x plus 1, x cubed plus 1 to the 2/3. And then this piece is going to be an integral. Okay, so this is going to be minus, but again, 2/3 canceling with 3/2, we're going to have the integral of x cubed plus 1 2/3. And now we're in pretty good shape. Now the only thing I need to do to finish this off, we have this integral that I have been ignoring for a little while, but we'll just bring that down. We'll just bring that down here. Adding it to this, we're going to have an integral of x cubed plus 1 2/3. You may see where I'm going with this because this integral and this integral is exactly the same. We're subtracting here, we're adding here. This cancels with this. We're just left with this, and so our final solution is going to be x plus 1, x cubed plus 1 to the 2/3 plus c. So that's it. I know it was a tricky problem today. Let me know if you had a different way or if this was just more intuitive to you. I'd like to hear if people had alternative methods for this, but this worked out okay for me. So we'll stop it there. Thanks everyone for watching today. Have a great day.